Hey guys, welcome to your second week of distance learning. Today we will be talking about minerals yet again. This is day 6 of minerals. We will be talking about some properties. Same thing, there'll be a supplemental video attached and it'll help you to see the things a little bit further. Okay, so we'll keep going. Just a quick reminder of what's going on this week. You have your tri-quarterly exam on Thursday. It's going to consist of about I believe it's going to be 40 questions and you're going to have 45 minutes to do it. It'll be all multiple choice. It'll be on Test Wizard. You'll be timed, so make sure you take it seriously. It will count towards your third quarter grade. All right, so I'll see you guys in a bit. You'll hear my voice throughout this video. See you later, guys. Hey guys, so we're going to keep talking about properties, and the property we're going to talk about today is crystal habit, which is just a fancy way of saying the shape of the crystals in a particular mineral. Most minerals tend to have only one particular shape for their crystals. Stuff like garnet and halite, they have rectangular crystals or cuboidal crystals or pyramid crystals, things like that. Some of them tend to have multiple shapes. So you might have something that has a cube and a pyramid, or a cube and a trapezoidal prism, things like that. Most commonly, they do tend to be geometric shapes, so stuff you've learned in math class. But there are some that are exceptions to the rule. We said that a lot in science. There's always exceptions. Okay, some of them have non-geometric shapes, but the important thing is that the shapes happen over and over again. So even though it's not a geometric shape, the pattern repeats, and so we consider that to be a crystal habit, and so therefore it meets our definition of being a mineral. All right, so here you can see a sample of halite. You can clearly see the crystals. It's nice and blocky. Okay. Halite is rock salt. It's the stuff you put on your driveway. The second one that you're seeing now is garnet. This is the birthstone for January. You can also see there's nice, clean, blocky, but a little bit longer, like rectangular prisms in that one. Okay. The mineral that you see up on the board right now is pyrite, iron pyrite, fool's gold. And you can see this is an example of a mineral having multiple crystal habits, and so you can see how some of them are boxy, but then some of them are more rhomboidal in shape. So this is a mineral that has 2 crystal habits. And then the ones that you're going to see on the board now, this one that looks silvery and kind of bubbly, those aren't bubbles, those are actually the crystals inside of it. Okay, and then the one that you're seeing on the screen now, that's the one that looks like it almost has like dinner plates. Okay, now this isn't coral or anything, this is an actual mineral, but you can see how the pattern in both of these things repeated itself over and over again, and therefore is considered to be a crystal habit. All right, guys, so the next property we're going to talk about is what we call hardness. So hardness is an object's resistance to being scratched. So a hard mineral would be hard to scratch. A soft material would be very easy to scratch. Okay, now those words are kind of open-ended. They don't give us a whole lot of information or a whole lot of things to compare to. So what we did is we created a scale. That scale is called Mohs scale of hardness. And so what we did is we took a series of minerals and we figured out which one was harder than which, and we assigned them a number value. And when we discover a new mineral, what we try to do is we try to figure out where our new mineral fits inside this scale of hardness. So if you're looking at the scale of hardness right now in front of you, what you can clearly see is that the softest mineral on there is what we call talc. Talc is the stuff that you make baby powder out of. Talc has a hardness of 1. Okay? All right, number 2 on the scale is gypsum. Gypsum is what we make drywall out of, the stuff you might have in your basement or in your walls. And as we work our way up, you'll see some that are familiar, stuff like calcite. Quartz is very important. That's number 7, makes up a lot of stuff. And then the top one is diamond. Diamond has a hardness of 10. Diamond is the hardest mineral known to man. The only thing that can scratch diamond is another diamond. Now, we don't always have these minerals on hand, so what we use is common objects. If you look on the left side of the chart, you see the right side of the chart, you see the common objects, okay? And you have things like your fingernail. Your fingernail has a hardness of 2.5, so it'll scratch anything that's softer than that. So like gypsum and talc will get scratched by your fingernail. Copper penny has a hardness of 3.5. It'll scratch anything softer than it, but it'll be scratched by things that are harder than it. The knife you see or the piece of glass has a hardness of about 5.5. Steel nail has a hardness of about 6.5, and a masonry drill bit has a hardness of about 8.5. Okay, so we use these objects to help us figure out how hard things are. If the mineral is scratched by the common object, then the common object is harder than it. So if your nail scratches the mineral, then your mineral is softer than 2.5. It's lower than 2.5. If a steel nail doesn't scratch it, but the mineral does scratch the steel nail, then the mineral is harder than the steel nail. All right, guys, so we're going to use hardness on our reference table. So turn to page 16 of your reference table, last page. You see it up on the screen right now. And if you look at this chart, you'll see that hardness is actually the second property listed. So it's the second vertical column. Okay, and the reference table is actually really nice in that it has the things organized by softest at the top, hardest down towards the bottom. So if we look at the chart, let's look at the third mineral on there, the one that's called magnetite. You see magnetite has a hardness of, good, 5.5 to 6.5. Okay, so if you have a hardness of 5.5 to 6.5, what does that mean? That means that any mineral that is harder than 6.5, let's just say, will scratch it. But any mineral that is lower than, let's say, 5 won't scratch it. So if we look at the chart, what would scratch a sample of magnetite? So if you took this mineral and rubbed it across magnetite, this would cause a scratch in magnetite. I'll give you guys a second to think about it. Okay, and quartz, topaz, corundum, diamond, all of these would scratch a sample of magnetite. What minerals wouldn't scratch a sample of magnetite? Fluorite, calcite, gypsum, talc. These guys are all too soft. Now, if we're talking the common objects, what would we be talking about? Well, magnetite's right at that 5.5, 6.5. So if we look at the common objects, you're between a knife and a glass plate. So if you took a sample of magnetite and rubbed it on glass, you probably would make a very fine scratch, but you probably would make a scratch. Okay? The steel nail, maybe not so much. The penny, magnetite would definitely scratch across it. Your fingernail, magnetite would scratch your fingernail. Your fingernail wouldn't be able to scratch magnetite. So I hope everybody understands what we're talking about here. Okay, so if we're looking at these guys here, okay, if you hear me clicking, it's because I'm going between tabs. Okay, if you look at all the minerals here, you should be able to say, okay, what would scratch what? Remember, the rule is whatever your number is, harder numbers will scratch you, softer numbers will not. You cannot scratch harder numbers, but you can scratch softer numbers. Hope that helps. All right, so the last property or properties are the unique properties that some minerals have that actually make them very easy to identify. One of the easiest is natural magnetism. A mineral like magnetite is a natural magnet. So you can see in the picture above you, you can see the paper clip sticking to that mineral sample. That makes it easy to identify. Magnetite was originally used in like the first compasses and things like that. Okay, the next property that we're going to talk about is some minerals have a unique taste. I know it sounds kind of weird to be licking minerals, but a mineral such as halite, which is that rock salt stuff we talked about, has a very distinct, incredibly salty taste. As you can see, you can only figure that out by licking the mineral, as you see the girl licking the mineral on the board. It's kind of funny, but it is true. There are some minerals also that have a unique smell. For example, sulfur has a very strong smell of rotten eggs. Okay, it smells like a fart, for lack of a better term. Okay, and sulfur is actually found in huge amounts in the yellow part of the egg, which is what gives the egg that smell. Okay, and when you wet sulfur, so if you wet your finger and rub it across sulfur, it gives off a very pungent smell. It smells like a fart. I keep saying it, but it really does smell like a fart. Okay, and then the last property we want to talk about is fluorescence under certain wavelengths of light. Now, what does that mean? It basically means that if you put it under something like a black light, okay, you guys know you have these like Halloween time and stuff like that. They're the purple lights. There's posters that light up. Okay, they use them for like IDs and clubs and stuff like that for stamps. Okay, but certain minerals fluoresce. They glow under UV light or other wavelengths of light. Example of that would be a mineral called willemite. Willemite is actually a mineral that you find in large amounts right here on the East Coast. There's a mine in New Jersey called Sterling Hill Mine. You guys should go. Really cool. The picture that you see right above you is actually a picture from Sterling Hill Mine. Amazing place. Quick little plug. You guys should go. Okay, but it's an amazing place, and you can actually see these different minerals that fluoresce. So if you find any of these unique properties, it makes it incredibly easy to identify the minerals. All right, guys, so that's it for the mineral properties. I hope you guys enjoyed that. There will be a supplemental video that we'll upload in a little while after this. Please make sure you look at that so that it makes sense. But otherwise, I'll see you guys tomorrow in the fun-filled world of earth science. Catch you later, guys.